Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 24 and today we are again going to solve a problem based on dynamic programming and the level of this question is going to be medium. The name of this question is word break. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on lead code. So here we are on lead code and the question says given a string s and a directory of strings word dict, return true if s can be segmented into a space separated sequence of one or more directory words. Note that the same word in the directory may be reused multiple times in the segmentation. So if you are reading this question for the first time, then you may found this question statement a bit confusing, but don't worry, I will break it down for you. So firstly, let's see some sample test cases and then we will think how we can solve this problem. Let's consider this particular test case. This is our string s and this is our word dict where we have some strings, or you can say that we have some words, right? And those words are lead encode and this is our string s. So we just need to split our string s into different substrings and those substrings should have these values, right? These values, lead encode. So let's say if I decide to split my string s into three substrings, my first substring would have value LWT lead, second substring would have value CO, and the third substring would have value LE. So is it the valid splitting? The answer is no, because you can clearly see that this lead is present inside my word dict, but this CO and this DE, they are not present inside my word dict, okay? This means that this is not the right combination. So let's say if I decide that my second substring would have only value CODE code, then here you can clearly see that this CODE is also present inside our word dict. Okay, so if I'm splitting this string into two substrings having values LWT lead and CODE code, so this string is successfully splitted into two words or into two substrings which are having values which are there inside my word dict, right? So if I'm able to successfully split my string into parts, right, then what I need to do, I need to return true. Similarly, let's take this second test case. So this is our string s and this is our word dict, okay? So I just need to split my string s into different substrings such that I should get these strings or these words, okay? So if I decide I will split this apple into a single substring, this pen into a single substring, and this apple again into a single substring. So here you can clearly see that this apple is present inside my word dict, this pen is also present inside my word dict, and this apple is also present inside my word dict, right? This means that this is the valid or the right separation of our string, okay? So for this particular sample test case, we have to return true. One thing which you need to note that we can have more than one substring having same values which are present inside my word dict. So I hope this is also clear to you. So now let's consider our third sample test case. So this is our third sample test case. This is the value of s and this is our word dict, okay? So let's say if I decide to split my string s in such a way that my first substring would have value CATS cats, second substring would have value A and D and third substring would have value OG. Okay, so I need to check all these three substrings are present inside my word dict or not. So this cats, it is present inside my word dict. This and it is also present inside my word dict, but this OG, it is not present inside my word dict. Okay, so you can clearly see that this is not the valid separation of the substrings. Okay, so we need to see some other combination. So let's say if I decide that my first substring would have value CAT only cat, and the second substring would have value SAND sand, and the third substring would have value OG. So here you can clearly see that this cat is present inside my word dict, this sand is also present inside my word dict, but this OG is not present inside my word dict. Okay, so for this particular string, it is not possible to split it into different parts such that we get these words. Okay, so for this particular string, we will return false. So I hope you have understood the question. So now let's think of how we can solve this particular problem. Let's take this particular sample test case to understand how we are going to solve this problem. we know that we need to split our string into different substrings. Okay, so let's say initially I have one variable named as I, and it is pointing at index number 0. So now what I'll do, I will try to split my string s into different substrings, and those substrings will start from index number 0. Okay, so let's say if I decide that I will split the string s into a substring of length equal to 1. Okay, so then my substring will have only letter s, right? And now I will check, is this s is present inside my verdict? You can clearly see that no, this is not present inside my verdict. Okay, similarly, let's say that if I decide that I will split this string s into a substring of length equal to 2, then my substring will have two values s and h. Again, I will check, is this substring sh is present inside my verdict? You can clearly see that no, it is not present inside my verdict. So now I will try to split this string s into a substring of length equal to 3. Okay, so now inside my substring I will have value s, h and e. And now if I check, is this substring is present inside my verdict, you can clearly see that yes, it is present. That means I need to split my string s at the index number 2. Okay, so this is the first substring, right? This is the first substring which is present inside my verdict. Okay, so now I need to look, or I need to search for the other words in the remaining part of my string. Okay, so I have got my first substring or first word in this part. Okay, so now I will start my searching from here, that is index number 3 up to index number 11, right? So the next question is how I will get the value of this index number 3. My substring is starting from index number 0. Okay, and my I is pointing at index number 0, right? Similarly, the length of this substring is equal to 3. So what will be the indexes? Indexes will be 0, 1 and 2. And the next index from where I need to start my searching is 3. Okay, so I can just simply add the value of I and the value of L. It will give me 3. So this 3 is the next index from where I should start my searching for the remaining words. So this is the next part of my string s, where I need to start searching for the words which are present inside my verdict. Okay, so now my I will point here at index number 3. So now I will try to split this string into a substring of length equal to 1. Okay, so if the length is equal to 1 of my substring, then my substring will only have one letter equal to h. I will check, is this h is present inside my verdict? You can clearly see that no, it is not present inside my verdict. So now I will try to make another substring of length equal to 2, which is starting from index number 3. Okay, so now my substring will have two letters L and A. And if I check, is this string HA is present inside my verdict, you can clearly see that yes, it is present inside my verdict. It means that this is the second part where I should make a split inside my string s. Okay, so now I will start my searching from index number 5. Okay, and how I'll get my index number 5? It is very easy. From the value of I and L, I just need to do I plus L. So the value of I is equal to 3 and the value of L is equal to 2. Okay, so here I will just write 3 plus 2, which is equal to 5. And this is the next index from where I should continue my searching. So this is the next part of my string s, in which I should start searching for the substrings which are present inside my verdict. Okay, so now my I will point here at index number 5. And again, I will try to make different substrings which are starting from index number 5. Okay, so if I decide that I will make a substring of length equal to 1 starting from index number 5, then my substring will only have one letter, and which is s. You can clearly see that this s is not present inside our verdict. Okay, similarly, if I decide that I will make a substring of length equal to 2, then my substring will have values s and a. You also know that this particular substring is also not present inside our verdict. Similarly, if I try to make another substring of length equal to 3, then my substring will have s, a and p. You can clearly see that this sap is also not present inside our verdict. Okay, so now we will try to make another substring of length equal to 4. Okay, so now my substring will have letters s, a, p and p. this particular substring is also not present inside our verdict. So now we will try to make another substring of length equal to 5. So now my substring will have S, A, T, P and L, right? And this particular substring is also not present inside our verdict. So I will try to make another substring of length equal to 6. So now my substring will have values S, A, P, P, L and E. And if we see, then this particular substring is also not present inside our verdict. Okay. So now we will try to make one more substring of length equal to 7. And now my substring will have S, A, P, P, L, E and S. Okay. So this is the substring which we'll get. And you can clearly see that this is also not present inside our verdict. So for this part of my string S, I was not able to make a single substring which was present inside my verdict. Okay, this means that it is not possible to split this portion of my string S to get a substring which is present inside my verdict. Okay, so now what I will do, I will simply return a false. Okay, I will simply return a false to the above function, saying that it is not possible to split this particular string to get words or to get substrings which are present inside our verdict. So before going into this part of my string, the last substring which I formed was of length equal to 2. Okay. So now I will continue making different substrings. Okay. My last substring was of length equal to 2. So now I will try to make a different substring of length equal to 3. So if I make a substring of length equal to 3, which is starting from index number 3, then my substring will have values H, A and S. Okay. Again, I will check. Is this substring is present inside my verdict? You can clearly see that yes, it is present inside my verdict. It means that I need to split my string from this particular part, right? At this particular index number 5. Okay. And now I need to search into the remaining part of my string, which is starting from index number 6. So how I will get this index 6? It is very easy. I will just add up the values of I and L. So the value of I is equal to 3 and the value of L is also equal to 3. So if I add it up, I will get 6, right? And this is the new index from where I need to continue my search. So now I will continue my searching in this part of my string and my I will point here at index number 6. So again, I will try to make different substrings which are starting from index number 6 of different length, and I will check one by one those substrings are present inside my verdict or not. So if I try to make a substring which is starting from index number 6 of length equal to 1, then my substring will have only one letter A, and this is clearly not present inside our verdict. Similarly, if I make another substring of length equal to 2, then my substring will have A and P, and this is also not present inside my verdict. Similarly, if I try to make another substring of length equal to 3, then my substring will have A, P and L, and this is also not present inside my substring. Similarly, if I make another substring of length equal to 4, then my substring will have A, T, P and L. By the way, by mistaken, here I have written L, here I will have P. Okay. So this particular substring APPL, it is also not present inside my verdict. Okay. So I will ignore this as well. So now I will make another substring of length equal to 5. So now my substring will have values A, T, P, L and E. So again, I need to check this particular substring is present inside my verdict or not. So inside my verdict, I have apples, but I don't have apple, right? It should have S at the end. But inside our substring, we do not have S. It means that this is also not present inside my verdict. Okay. So now I will try to make another substring of length equal to 6. So now my substring will have A, P, P, L, E, and it will also have S. And you know that this particular substring is also present inside my verdict. Okay. So now in this particular string, I need to make a split at this particular portion. Okay. At this particular index, after this index number 11. So now I need to continue my searching with the next index, which is index number 12. Okay. I know that this is invalid index or we are going out of bound, but have some patience. I will explain you that why I am using it. Okay. So now I will move to the next part of my string, which is at index 12. So now my I will point here at index number 12. But you can clearly see that we don't have any index equal to 12 into our string. The last index was 11. So you can clearly see that we have came out of bound. Okay, and we can also say that this 12 is nothing but it is the size of our string s. So if my eye is pointing at the size of my string s, it means that I have successfully completed my traversal and I was able to successfully split my string into different substrings, and those substrings were present inside my verdict. So here you can clearly see that I have successfully splitted my string s such that I got one substring which is apples and it is also present inside my verdict. I got another substring has and it is also present inside my verdict. I got one more substring SHE and it is also present inside my verdict. It means that I have successfully splitted my string into different parts and those substrings were present inside my verdict. So now from here what I'll do, I will return a true, okay, to my previous function, right? So here at this particular function call, I'm receiving a true. So what I'll do, I will also return a true to my parent. Okay. So now at this particular function call, I'm also receiving a true. So what I'll do, I will pass it to my parent function call. Okay. So now I will return a true to my parent, right? And here at this particular function call, I am receiving a true. Okay. So what I'll do, I will again return a true, indicating that yes, it is possible to split this string s into different substrings and those substrings are present inside my verdict. Okay. So this was the dry run. This was the approach which we are going to use in order to solve this problem. So I hope it is clear to you. If you have some doubts, then do some dry runs by your own by taking some different examples. Then you will definitely understand this approach. So let's say that we are having one function named as solve and it will be of Boolean type. It will return either true or false. Okay. And inside this solve function, we are getting our index I. Okay. And we are also getting our string s, right? So what is the very first condition? The very first condition is going to be if my I is greater than or equal to the length of my string, right? So I am assuming this s is the size of my string s, or you can say the length of my string s. If this is the condition, then I have to return true. Let's say that I'm having a string a b c d, right? And my I is pointing here. Okay, so what I need to do, I need to make different substrings, right, of length equal to 1, length equal to 2, length equal to 3, up to my length is equal to n. Okay, so for that what I can do, I can use a for loop. Okay, so here I will write int l is equal to 1 and it will go up to it is equal to n. Okay, so how do we make substrings inside C++? It is very easy. So I will declare a string. Let me name it as substring. Okay, and now I will use the inbuilt function substr on which string? On string s. Okay, so here I will write s dot substr, right? And inside this inbuilt function, I need to pass on two values. The very first one is the starting index of my substring and the second is the length of my substring. So we know that the starting index of my substring will be nothing but I. Okay, so here I will write I and the length of my substring will be L. Okay, will be L, right? So here I will write L, right? So in this way we will form our substring, right? So now I need to search this particular substring is present inside my verdict or not. So while I was explaining you the question, I also mentioned that this word dict, it is nothing but a vector. Okay, it is a vector of strings, right? So now I have one substring and I need to search this substring is present inside my vector or not. So if I search inside a vector, it will take me O of n time complexity. Okay, so it is better to store all the strings which are present inside my verdict into a set. Okay, so if I store all the strings inside a set, this will be our unordered set. Okay, so if I store all the strings which are present inside my verdict into a set, then searching will be easy for me, right? Searching any particular element inside one unordered set will cost me O of 1 time complexity in average case. Okay, so what I'll do, I will put all the elements of my verdict inside a set. Okay, so let's say I have already put it all of my strings which are present inside my verdict into one unordered set and the name of this unordered set is nothing but st. So I need to pass this unordered set inside my solve function. So here I will use my unordered set st. Okay. So we need to search this particular string, substring. This particular substring is present inside my set or not. Okay. So for that, here I will write st, which is the name of my set. Okay. Here I will use one inbuilt function name as count, and here I will write my substring. Okay. Here I will pass my substring, right? So this count function will return true if this particular substring is present inside my set, or it will return false if this particular substring is not present inside my set. Okay. So if this particular string is present inside my set, then I need to check for the other part, for the remaining part of my string. Okay. So for that, I will take help of recursion, right? So here now I need to start my searching from which index? My searching will start from index number I plus L. Okay, I hope you remembered this, and I will pass the other values, string and my st. Okay. So if both these two conditions are returning me true, it means that my substring is present inside my set st, and this particular solve function is also returning me true. It means that what I'll do, I will also return true to my parent function. Okay. So I hope you have remembered this, that whenever we are returning a true from any function call, we will also return true to our previous function. Okay. So here I will return true, and here this for loop will get ended. Okay. So if let's say that I have tried all the substrings of a particular string and none of them matched with the verdict. So in that particular condition, what do we need? We need to return false. Okay. So therefore here I will return false. Okay. So this is going to be our code. Okay. I hope it is clear to you. And if we talk about the time complexity, then here the time complexity of this code is going to be exponential. And if we talk about the space complexity, then we are using one set st. Okay. So let's say that inside our word dict, we are having total of k elements. Okay. So the size of this st will also be equal to k. Okay. And we are also using recursion. We are calling different recursive function. Okay. So it will also take some function called stack. So it will take total of n space. Okay. Where this n is nothing but the size of a string s. So at max, it will take size O of n. So if you are wondering why this time complexity is exponential, let me explain it to you. So in this particular recursive call, I hope you have remembered that we made one function call with the index I equal to 5, right? Or with this particular string. And we also made another function call with I equal to 6. Okay. So you can say that at one index, I made more than one function call, right? So in worst case, all the indexes will have more than one function calls, due to which my recursion tree will look something like this. Okay. Or you can say that my recursion tree will expand exponentially. Okay. Therefore, the time complexity for this problem is going to be exponential. So right now, the time complexity of this solution is going to be exponential. Okay. And if we submit this particular solution, we will get surely TLE on lead code. Okay. So we need to optimize this. How we can optimize this? But before optimizing, we need to understand why do we need to optimize. Okay. So we know that if I'm standing at any particular index, I can make more than one function call. Okay. Similarly, if I'm standing at this particular index, I can make more than one function call. So there can be some overlapping cases. Okay. I hope that you understand what I mean by overlapping cases. So what we can do is we can use one vector to store the result of those overlapping cases, so that we will not recompute those cases. Okay. So I hope that you are familiar with these terms. Okay. It is nothing but a top-down approach or a memorization approach. So now we need to check that which parameter is getting changed again and again whenever I am making a new function call. So that parameter is nothing but I. Okay. Here you can clearly see that whenever I am making a new function call, I am changing the value of I. Okay. And what will be the range of this I? So it will start from 0 and it will go up to n minus 1. Okay, so there can be n number of values of this I. Okay, so therefore what we will do, we can use one vector. Okay, let me just name it as dp, and the size will be equal to n, and initially we will have minus 1. Okay, and here, before calling this for loop, I will check that if dp of I is not equal to minus 1, then just simply return dp of I. Okay, and similarly, before returning, I will store the answers. Okay, so here I will write dp of I is equal to true, and here also I will write dp of I is equal to false. Okay, so if we are using this particular vector, then my time complexity will boil down, it will boil down to n square. Okay, it will get boiled down to n square. So now we are here on lead code. So very firstly, I need the size of my string s. Okay, apart from this, I also need one unordered set which will store the string values named as st. So this string st is going to store all the strings which are present inside verdict. Okay, so I can directly write it here, verdict dot begin and verdict dot end. Okay, so now all the strings which are present inside this verdict vector will get stored inside this string st. Okay, so I hope it is clear to you. Now I also need one vector, let me name it as dp, and it will have n size, and all the values inside this dp vector will have value minus 1 initially. Okay, and now I need to call my solve function. So inside my solve function, I will give my initial index, which is 0. I will send my string, which is s. I will string my set, which is st. I will send the length, and I will also send my dp. Okay, and whatever this solve function will return to me, I will return it. Okay, I will also return it. So here the spelling of return is wrong, return. Okay, right. So now we just need to write the solve function. So here I will write bool solve int I and string s. So I am just receiving this s by reference. Okay, and I also need to receive this uh, set st. Okay, so let me just directly copy paste it. Here also let me write ampersand. I'm just uh, receiving it by reference. Okay, and I also need my vector of int named as dp. Okay, so the very first base condition is that if the value of I is greater than or equal to n, then you just need to return true. Okay, second condition is if dp of I is not equal to minus 1, it means that we have already calculated the answer for this particular index I. Then we just need to simply return our dp of I. Okay, and now we need to make a for loop. So here I will write int l is equal to 1, l is lesser than or equal to n, and the l plus plus. Okay, so very firstly I need to make different substrings. Okay, so here I will write string sub string substring is equal to sub str. Okay, but I want to call this substring function on my string s. Okay, so here I will write s dot substr, and here I will pass the index, the starting index of my substring. So it is going to be I, and the length of my substring, which is going to be l. Okay, so now I will check this particular substring is present inside my set or not. For that I can write st dot count sub string. Okay, so this st.count will return me true if this particular substring is present inside my set. Okay, so if it is returning me true, then I will make my next function call. Okay, so here I will pass I plus l, and I will pass the other values such as s, st, and dp. Okay, but I think I forgot to receive this value n. Okay, so after this st I will write int n. Okay, and here also I will pass the value n, right? So I'll not have semicolon here. So see, if both these two conditions are satisfied, right, then what we will do, we will return true. Okay, and before returning true, we will store it inside our dp. Okay, so here I will write return dp of I is equal to true. Okay, and after this for loop, I will write here return dp of I equal to false. Okay, so if I have tried all the possible substrings and still I haven't received true, right? Then only I will come out of this for loop. Okay, so in that particular case, I am returning false, right? So this is our code. I hope it is clear to you. Let me run this. So here I just forgot to add one comma, and now let me run this. I hope it should run fine now. So here you can clearly see that all the 3 sample test cases are running fine. Let me submit this. So here you can clearly see that this particular solution is accepted, but this is again not the most optimal one for this question. But we will discuss the optimal and better approaches in our next upcoming videos. So I hope this video was helpful to you. If it was, then make sure that you like to this video. Don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel as well. We will meet again tomorrow with a new question.